Hello there. Today we'll be doing tries. We'll implement a try and check out this data structure. It is a pretty cool data structure. It's like a tree, but it has multiple children. So what does this node look like with multiple children? Well, it's let's try something simple. Let's try an A, B, C, D, and D, C, E, D, E, F. So in this particular item here, we're talking about different layers, and the last item would be our there are where our childrens exist. So like this, we have an A. So let's say we had a word AB. We put that in C, and those are our children. And with D, we also have children for D. So each child can have multiple children. So D, E, and F. And as you can see, this is a trie tree. So what's a quick way to implement that? The quickest way is to use a class called, we'll create a class called trie node. We'll create it here actually. Class trie node. And in each node, what we're gonna do, this is an internal function. So what is A? Well, it has children. What are children? So self.children are going to be equal to default dictionary of trie node. So whenever we ask for this particular item, we will create a trie node for it. And this particular children will have a, we'll start with a an item. So let's create that dummy. So self.root, we could call this a dummy, equals trie node. So this does not have any numbers or alphabets sticking to it. It's just a trie node, and it has children. One thing to note about children is that we're going to insert items into the children, but when we need to search for it, we need to know whether it is a prefix or a word. We're going to be inserting items into this trie, and we have to search for the item by traversing through the tree, and we have to either like know whether it's a prefix or not a prefix. So what we're going to do is self.isEnd. Is this the end of the word? We'll set it at false to begin with, because we don't know, and if it is the end of the word, then we'll set it to true. Let's insert some words. So to insert some words, let's say for character in word, let's say, oh right, we need to get a current equals self.roots. That's how we get started. Cur equals cur.children at this particular trie node, let's say char. Okay, and it will develop itself, and we'll go to it. And once we're done, we can say cur.isEnd equals true, and that's it. That's all of it for the insert item. Okay, next, let's separate this out a little bit. Okay, anything else? Let's search. Let's search this word. So cur equals self.roots. So for char in a word, basically every word, if char is not in the cur.children, that means it is not available. So return false. Otherwise, we could cur equals cur.children at char. And once we hit the end, we can just return cur.isEnd. Next, we basically repeat the same code, basically, but we just return true because, well, we found it. With that, we are done with this particular problem, and we can return. Something to note is that we could do better by fixing this and reducing the amount of code we could get wrong. We could do an internal function. So this is like this: underscore find yeah, do a find. It's very broad. Self, and then do a string. That's very broad as well. And then we'll return a bool. One thing we need to add in is that is prefix or is word. I don't know, but you can do either. So with that, we can do is prefix, and we can just grab this code here, copy, paste, and what we're gonna do is change this prefix to a string, and we're gonna change this as if is prefix, then return true. Otherwise, it's a word, so return cur.is end, and that's it. And so we can use this find. We can do return self find the prefix is prefix, and we'll set this to true, and we'll set the other part to false, and that would be it. And submit. So as you can see, this code is a little bit cleaner because we only have to look at find, and we can see this code, and we can only look at differences between the two. Easier to read, maybe easier to maintain. And yeah, that's it. That's it for all of this. I hope you learned something today about implementing classes, and specifically the Trie class. So if you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. And if you have any questions, comment in the comment section below. And I will see you in the next one. Thank you. Bye.